No questions on this night so far? That's the hardest of the three. That's the ones you can see on the test. Well, if you remember that we drew this graph a couple of days ago, or was it yesterday? No, a couple of days ago, then you would just see the answer already. All real numbers. Yes, in the domain of the problem. Okay, but most of us don't see it, so then you're either gonna sine both sides or cosine both sides. You can move one of these on the other side. Like if you're clever, did some of you move one of these on the other side? And then you can use the co-function identity, right? Cosine of pi over 2 minus x is sine x. Whatever. What do you guys want to do? Move one over? Just cosine both sides now? Sine both sides now? What? It doesn't matter. Just pick one and go with it. Like if you had a choice, sine, okay, let's just say we're just going to sine or cosine both sides. Which one would you pick? You don't even have a choice. Cosine, because cosine pi over 2 is 0, right? Yeah, but sine pi over 2 is 1, Mr. Park. Yeah, but it doesn't matter. Okay, let's cosine both sides, because 0 is easier to work with than 1 for most people. Okay, and like I said, cosine pi over 2 is 0. Okay, now, how do you do this? Cosine of the first. Why don't we draw triangles for both of these before we even start? Cosine inverse x means adjacent over hypotenuse, and then you use the Pythagorean theorem. Sine inverse x would be opposite over hypotenuse, and then you use the Pythagorean theorem. Then move this down then. Okay, what's the identity for cosine gorilla plus banana? Cosine of the first. Look at this one. What is the cosine of this? X. Cosine of the second. Minus sine of the first times sine of the second. And that's equal to 0. Hey, but Mr. Park, these two cancel out. You get 0 equals 0. Yes, that's what I'm talking about. Yeah, but that's what I got, Mr. Park. Yeah, then you're doing it correctly. If all the variables cancel out, then either the answer is no solution or all real numbers. If you end up with a true statement like this, then it's all real numbers. If you end up with something that's not true, like 1 equals 0, then the answer is no solution. So the answer in this case is all real numbers in the domain of the problem. What is the domain of these two functions? Between -1 and 1. And that's why that's the answer. It's all real numbers between -1 and 1, including -1 and 1. What do you mean, domain? You're joking me. Okay, let's look at the graph of cosine inverse. I believe it looks like this. What's the domain? Isn't it from here to here? There's no graph out here. There's no graph out there. That's the domain. And same thing for sine inverse. See, that's why I put that problem on people. Okay, F. Okay, but probably on the next quiz, you're going to have one like this. And then on the test, of course, we kicked up another. Okay, well, you got two choices. What do you want to do? Tan both sides or sine both sides? There are two tans. You know why that's better? Because tan of tan inverse iguana is iguana. Yeah, but sine of sine inverse iguana is iguana too. Can you see why? Oh gosh. That's because this argument is more complicated than this argument. Okay, we're just going to tan both sides already. Tan And it's easier to draw the triangle for this one than that one. Not really. It's only by a small bit, but why am I putting these extra parentheses? Strike one. Okay, tan of tan inverse gorilla is gorilla. Now, how do you find the tan of sine inverse x? You draw the triangle. How do you draw an angle that's sine inverse x? Opposite over hypotenuse, and then you use the Pythagorean theorem. So what's the tangent of that angle that I just drew right there? Opposite over adjacent. People, once you draw the triangle, everything is just, it just falls into place, right? Just draw the triangle. Okay, now how do I solve an equation like this? Cross multiply. Now what? Cancel x from both sides and lose the solution. No, don't cancel. What do you want to do? How do I get rid of the radical? Oh, no. Oh, you want to make one side 0 now? Well, you're going to have to square both sides sooner or later. You want to do it now or later? What, you want to do it now? Okay, square both sides. 4x squared times 1 minus x squared equals x squared. Boom. 4x squared minus 4x to the 4 equals x squared. Make one side 0. 4x to the 4 minus 3x squared equals 0. Factor out an x squared. So you get 4x squared minus 3. Setting each factor equal to 0. X equals 0, or, what about from this one? Plus or minus root 3 over 2. Hey, those are numbers I know. Now, I'm going to write them separately. You know why? Because we might have to cross out some of these. So, Bob said that's the answer. No, I told you yesterday you have to check because of the restricted range. So you have to check all three of these values back into the original, and I will let you do that. Anyway, got the answers on the bottom. Where's the answers? Hey, they all work. You know how you can tell? They're all there on the bottom. Yeah, but the problem we did yesterday, the one of them didn't work, right? And then G. Okay, now, you can tan both sides now, but wouldn't it be easier if you move one of the, because you got three things on the right. Who wants to go tangent gorilla plus banana plus iguana? Not me. Why don't you bring one of them over on the left side, and then you just have two on both sides, so when you tangent, that's easy, right? So which one you want to bring over? Okay, the first one. Okay, have it your way. R. And 2/3. Anyway, did you guys use the math team method I taught you yesterday? Draw the picture before you start and guess at the answer. And then, here, this is special forces training right here. Okay, arc tangent 2. You make opposite over adjacent, 2-to-1 ratio like that. That angle is arc tangent 2. And now we're going to add to that arc tangent 2/3. So 1, 2, 3, 1, 2. See, if you make the ratio 2 to 3, then isn't that angle arc tangent 2/3? Opposite over adjacent. And then we have to add to that arc tangent 7/9. So if this is 9, 7 would be a little bit smaller than that, so about like that. So if I add these three angles together, what does that look like? It looks like 3 pi over 4 to me, but now let's verify. So see, on math team, this is what we do. Here's the answer line. We write down 3 pi over 4, and then now we verify it. Okay, so what I'm going to do now is I'm going to tangent both sides. So you tangent the left and you tangent the right. So tangent of the first minus tangent of the second. What's tangent of arctan 2? 2. All over 1 plus tangent of the first, tangent of the second, equals tangent of the first plus tangent of the second, all over 1 minus tangent of the first times tangent of the second. Now, if we are right, if that's our guess, if we're going to be right, what is it going to have to come up with? Tangent x equals -1, because tangent of 3 pi over 4 is -1. So if we're correct, then that's what should happen. So what I would do if I were me, I would simplify this because that's too ugly. Multiply top and bottom by 20, oh yeah, no, 27, look, right here, come on. So 18 plus 21 all over 27 minus 14, which is 39 over 13, Now, I remember giving a problem like this on last year's test. You know what they do? They just leave it 39/13 instead of reducing it to 3. In fact, in my calculus test yesterday, so many people don't reduce. They get 30/40 and they keep working with it, and it's just all crazy numbers. Reduce it to 3/4 for Pete's sake. Okay, now cross multiply. This is like 3/1, right? So tan x minus 2 is equal to 3 plus 6 tan x. 5 tan x equal -5. Tan x equal -1. See? 3/4 was correct. What if on the test, Mr. Park, I just draw it and I put that with no work? I would give you 2 out of 8, because you got the correct answer.
What if we guess wrong and our answer doesn't verify it?
Then you get it from here. You do it the way I taught you yesterday then.
Okay.
Tangent of what angle is -1? This is the same thing. Remember, there's an infinite number of answers. Remember I wrote this? -π/4, 3π/4, 7π/4, ... Pick out the right one. So then you draw the picture. So out of all of these, which one looks like that? Wouldn't it be this?
Like if we draw the picture wrong.
Yeah, well how can you draw it wrong?
Careless work.
Yeah, but still it's going to be kind of close to that, right? It's not going to be anywhere near -45 or 315 degrees, right?
Yeah.
They're like 180 degrees apart. No, not even my dog can draw that badly. He has problems holding the pencil in his paw. Okay, next, we could do the rest. Good thing, because we got to learn today. Okay, today, so that's the end of inverse trig functions. Now, I'm not going to ask you to graph on the test, which is going to be, I don't know, you guys can probably map it out already, yeah? I'm not going to ask you to graph on the test, but I'm going to ask you questions about a graph. Which means you got to know what the graph looks like anyway. Okay, today we start tri-trig, triangle trigonometry. Anyway, you know what trigonometry is, right? It's the study of triangles. So today, we're just going to, anyway, if you look at the notes, I give you all the formulas that you learned last year, and even from geometry, key round formulas, some of you forgot. Okay? But if I give you a triangle, you have to be able to compute things about it, like the sides and the angles. Okay, now today we're going to start off easy. Pretty much, you just got to use SOHCAHTOA. Okay, here. Now, I don't know if you're going to, this is too easy, but this is the kind of problem you get on the ACT. Some of you signed up for the ACT already? You should take the ACT, you should take the ACT at the end of your junior year if you are going to take it. Or SAT 2, Math Level 2, this is subject test, at the end of your junior year. Anyway, this is the kind of problems you have. Okay, here's a flagpole, and you want to measure how tall it is. So what you could do is you go back maybe 100 feet. 100 feet? Is that feet? Yeah. And then you can measure the angle of elevation. You guys know the difference between the angle of elevation and the angle of depression, right? From last year. Angle of elevation is the angle that you're looking at the thing. So this is the angle of elevation. Let's say the angle of elevation is 42 degrees. You guys know what angle of depression is? It's this one over here. Angle of elevation and depression is always measured from the horizontal. Oh, so they're the same. Yeah. How tall is the flagpole? Now, if you have a right triangle, you use SOHCAHTOA. Now, which one do I use? Sine, cosine, or tangent? Well, here's the angle. What is this side? This is the opposite side. This is the adjacent side. Which one has opposite and adjacent in it? So, ka, or to? Tangent! Tangent now, 42 degrees is equal to x over 100. So therefore, x equals 100 times tangent of 42 degrees. And now you can punch that in your calculator. Now, starting today, you can use your calculator. Okay, now, if I were you, and what's going to happen is you're going to be flip-flopping between degrees and radians now. So when you do this kind of problem, when you're just computing trigonometric values, you want to keep your calculator in degree mode. But when you're graphing something on your calculator, it has to be in radian mode. So you got to flip-flop between the two. You got to know what mode you got to be in. Anyway, you punch that in, and that'll tell you that. In fact, on the ACT, this is how they list their answers. This is A, and then they have B, 42 degrees, C, sine 42 degrees, D, 100 times secant 42 degrees, and then E, none of the above. Of course, pick A, right? You just gotta know sopatoa. And what about areas of triangles? If you know all three sides of a triangle, what's the fastest way to compute this area? Heron's formula, right? Which is, we talked about this already. What if you know two sides and the included angle? Now I'm assuming we know the basics about triangles. We use lowercase letters to represent the sides and capital letters to represent the angles. Side A is always opposite angle A. We learned this last year, right? Okay, so if you know two sides of a triangle and the included angle, what's the fastest way to find the area? No. We're not going to use law of sines until tomorrow, law of sines and cosines. What's the fastest way to find the area of this triangle? We learned this last year. 1/2 AB sine C. Does that even look familiar? Do I even have to review the other formulas? If you have a circle, here's the center, here's the radius, okay? You make a central angle like that, theta. How do you find the length of this arc? S equals r theta. Theta got to be measured in radians, right? How do you find the area? Yeah, 1/2 r squared theta, right? These formulas. Come on, you guys took trigonometry last year. This is all in the book. I never learned those formulas, Mr. Park. I forgot. Okay, well, let's pretend you don't know anything. What's the area of a whole circle? Pi r squared. What fraction of the circle is this pi piece? Isn't it theta over 2 pi? Theta is measured in radians now. And then look, the pi's cancel out. What do you get? Right, just like the arc length formula, what is the circumference of a whole circle? 2 pi r. But what fraction of the circle is this angle? Theta over 2 pi. The 2 pi's cancel out, you get r theta. You know what? See, the problem is last year, you guys just memorize all these formulas, take the quiz, forget it. What about this formula? Where did this come from? Okay, let's review something for those of you who didn't take physics. If you know the hypotenuse and you know this angle, how do you label this side right here? We went over this several times already. And you guys in physics, if you don't know this, you just hang your head in shame. This is how you componentize vectors right here. H cosine theta is the adjacent side, and H sine theta is the opposite side, correct? That's how you componentize vectors. What? Okay, so look at this triangle right here. This angle is angle C. If I drop the altitude down here, what is the length of this altitude? Look, here's the hypotenuse. It's going to be A what? Cosine C or sine C? It's opposite, so it's sine. So how do you find the area of this triangle? 1/2 base times height, and that's how you get this formula. So tonight's homework, basically, you just have all these formulas in your tool belt, hopefully, and then you get a problem, and then you got to figure out how to solve it. That's why this is fun, this chapter. Everything is just unadulterated fun. Okay, let's do another problem. Tonight, are you doing a nonagon or a decagon? Tonight's homework. Nonagon or decagon? Or a 12agon? Nonagon is tonight's homework, so I'll do a decagon on it. What's a decagon? A decagon is a, oh gosh. A regular decagon, how many sides does it have? 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey, that's pretty good. What do you want the side to be? Give me a number. 1. How creative. Okay, we have a regular decagon with side 1. What is the area? So tonight you got nonagon. What do you do? Is there a formula for that? Yeah, from geometry we learned the formula 1/2 AP, right? Remember? 1/2 the apothegm times the perimeter. Yeah, but we really don't need a formula. Some of you don't even know what an apothegm is. Is it an apothegm or an apothegm? See, you don't even know that. How about draw this in? If I can find the area of this triangle right here, then just multiply it by 10, right? Because it's got 10 of them, right? See, just break it down into things you know. Okay, so how do you find the area of this triangle? What do I do? Well, I know this is 1, so if I draw... Now remember, tonight we're using SOHCAHTOA, right? We need right triangles, so you draw this in, so a right triangle is formed right there. So if this is 1, isn't that a half right there? Okay, now I got to figure out an angle. How the heck do you expect me to figure out an angle, Mr. Park? Well, if you have 360 degrees in a circle here, like this, then shouldn't that angle there be 1/10 of it, since there's 10? So what's 360 divided by 10? So that's 36. So when I drop the altitude down there, then shouldn't this angle here be 18 degrees then? Oh, and I got a right triangle. I can use SOHCAHTOA. So what I wanted, and for those of you who don't know, this is the apothegm right there. Apothegm is the segment that goes from the center perpendicular to the side. But you don't have to know what that is. We'll just call it A for anything. Okay, so which trig function should I use to find A? Sine, cosine, or tangent? Well, what do you know? What are you trying to find and what's given? Here's the angle. This is the opposite side. This is the adjacent side. Which one has opposite and adjacent? We just did that. Tangent, TOA. Tangent of 18 degrees is equal to 1/2 over A. So therefore, A is equal to, I'm going to change the 1/2 to 0.5 because it's making me uncomfortable. 0.5 over the tangent of 18 degrees. So therefore, the area of this triangle is 1/2 the base, which is 1, times the height, which is this, 0.5 over tangent of 18 degrees. That's the area of this one triangle right here, but then you gotta times it by? This is a decagon, not a 20-gon. 10. Then you gotta times it by 10. Now you can punch that in on your calculator, boom, you get the answer. Don't take out your calculator to like the very last step. Whatever, it's up to you. Now when you use okay, the bell's gonna ring soon. When you use a calculator, you cannot use a rounded value in another computation now. So if you get a value, like some people like to compute the tangent of 18 degrees, you can't just use 3 decimal places because you're gonna get a rounding error in the answer. So if you have to use a rounded value in a computation, store it. Remember I taught you how to store back in first quarter? And then you just punch in that letter. You can store it in A through Z. Oh my goodness, we're in trouble. Clock, I need to speak to you. Let me turn off the camera so there's no swearing.